Okay, welcome to video number 4 and page 4. We are still identifying the properties of logs here. So I have log 3, 9x plus 2 is equal to 4. And we were able, there is a typo on this one. There is a typo on this one. What we're going to do here, it's the easiest way to fix this. We're going to change this log base 3 to log base 2 just to fix that typo. So this got uppercutted, but that's not the actual name of it. This is actually the inverse log property. It allows us to do the uppercut. You're actually raising everything to the base of 2. So you're turning these into exponents with the base 2. And then that would cancel out the log base 2. So this is the inverse property. So this one, we are going to, looks like they're taking they cancel out, so this turns up missing. So it looks like they canceled out the log of both sides. So what happened here was they took log base 3 on this side and log base 3 on that side to cancel out that 3. So this was the other direction of the inverse property. This is the opposite of the uppercut. I guess it would be the lower bandage. I don't know. The inverse property, though. The natural log of 1 is equal to 0. That's just the 0 property, I believe they call that one. Natural log of 1, so e to the 0th power is 1. So it's the 0 property. Yeah, I do believe it's the 0 property. Okay. Solve each exponential or logarithm. Find exact values, so you shouldn't need a calculator. So what we're going to do here is we're going to get these to a common base. So 2 to some power is going to equal 64. If I play around with that for a little bit, we know that this is going to be 2 to the 3b minus 2 is equal to 1 over, I do believe that's here, 2 to the 5th is 32, and double it again, so that should be 2 to the 6th. So we're not quite to a common base yet, so we're going to use a property of our exponents, which allows us to take this 2, bring it out of the denominator, and make that a negative 6. So now that we have a common base, mathematically you would take log base 2 of both sides to bring them down, but we can just get rid of those. 3b minus 2 is equal to negative 6. And now it's a regular old boring algebra 1 problem. Add 2 to both sides. That gives us 3b is equal to negative 4. Divide both sides by 3. And we get b is equal to negative 4 over 3. Done. Okay. This next one, again, common base. 64 is a power of 4. Yeah. So you can either reduce this to a power of 2 and this to a power of 2 if you want. That's fine. I'm going to do the slightly shorter version of reducing it to a power of 4. So that's 4 to the 3rd, 3v, is equal to, and 4 to the negative 1, and I have a negative 3v minus 2 in the power here. So now we're going to simplify these exponents real quick. So power to power is multiplication, so that's 4 to the 9v is equal to, now this is where a lot of people will get tripped up. You got to make sure you distribute this negative 1 to the negative 3 and the 2. So there's an understood parentheses out here. So it's going to be 4, negative 1 times negative 3v is a positive 3v. Negative 1 times a negative 2 is a positive 2. Now we have like bases, so they will go away. And we're given 9v is equal to 3v plus 2. Subtract 3v from both sides. Oh, that gives us 6v, yep, is equal to 2. And then we divide both sides by 6. V is equal to 2 over 6 is 1/3. One more of these. So 9 to the 2x, we can bring 81 to a power of 9, is equal to 1 over 9 squared to the negative x, I believe that says. So this is 9 equals 9 negative 2, 9 to the negative 2 to the negative x. Oh, sorry, 9 to the 2x, right? Yeah. So then simplify 9 to the 2x equals 9. Negative 2 times negative x is another 2x. The 9's cancel out. 2x is equal to 2x. Subtract 2x from both sides. And we get 0 is equal to 0. So no variables, and this is true. So infinite solutions. Okay. Next bit. Use a calculator to approximate the value of each variable, round to 3 decimal places. I did not bring a calculator, so what I'm going to do is I'm going to solve it up to the point where you would need a calculator, and then you can just punch it in to verify that you got that far. So what we're going to start with here is we're going to add 5. We're going to get the power by itself, collect all our constants to another side. So negative 5, we're going to add 5 to both sides. So we will add 5. That will give us 16 to the 5n is equal to 48, negative 48. Negative 48. Unfortunately, 48 is not a power of anything. So our next step is going to be take the log base 16 of both sides. So that would cancel off that one to give us 5n comes out of the denominator, or out of the new, sorry, out of the power. And this side becomes log base 16 negative 48. Now there are ways you can simplify this a little bit if you wanted to. without a calculator. I'm not going to really worry about that. We'll divide both sides by 5. So we get n is equal to log base 16 negative 48 all over 5. Punch that into a calculator, and it should give you an exact answer. You can punch in a calculator using the change of base formula here. But I will get that, and I'll have the answer tomorrow on in class. Okay, next section here. So 4 times 13 to the 4a. So we need to solve for a. Start by dividing both sides. Divide both sides by 4. So that would cancel out that, giving us 13 4a. 4 divided by 4 is 1. So then we take the log base of both sides. So log base 13. So that would cancel that out, leaving 4a on that side is equal to log base 13 of 1. This one you actually don't need a calculator if you know your properties of logs. Log base 13 of 1, or any log of 1, is equal to 0. So 0 property of logs. 4a is equal to 0. Divide both sides by 4, and a is equal to 0. So we're able to find an exact value with that, even without a calculator. Fun. Next one. So we have 4 to the k minus 6 plus 4 equals 38. So get our exponent by itself first. So we need to subtract 4 from both sides. 4 to the k minus 6 is equal to 38 minus 4 is 34. Then once again, take the log base 4 of both sides because we want to cancel out that base 4. So that gives us k minus 6 is equal to log 4 of 34. And then we will add 6 to both sides. K is equal to log 4, 34, minus 6. No, plus 6. Plus 6. Punch that in your calculator and it should give you the answer. K is about, this should be N is about, and I'll have those answers for class tomorrow. I just didn't remember my calculator. See, I told you, and all the math teachers will do it for you. You won't always have a calculator on hand. See, they can predict the future. 6 more on this page. Compared to the parent function, f of x equals 2 to the x, how are the following graphs transformed? So if we are subtracting 7, so we're subtracting 7 from the whole thing, that means that we have moved the entire graph down 7 units. If we've added 7 to the x, so remember whenever you're adding it directly to the x, it's moving in the opposite direction. So this will be moving in the negative direction, which is left. So this should go left 7 units. Okay. -2 is going to, it's a reflection. It's a reflection, and it's going to be over the, so that would make the whole thing negative. So it's going to be a reflection over the x-axis. The easiest way to remember which axis it's being flipped over is you can just straight up memorize it. Or if you're doing negative to the whole thing, that means that the parent function can never have a negative answer, right? This is, the asymptote here is 0, and everything's going to be above 0. But if I make the whole thing negative, that means I've flipped it to where there are no positive answers. So that means that it's gone from all positive answers to all negative answers, which is a reflection over the y-axis. Oh, sorry, not the y-axis, the x-axis. Okay, 3 more. Compared to the parent function, f of x equals log base 2 of x. How the following graphs transformed. So log base 2, again, we're subtracting directly from x, so that means that this will be going in the positive direction. So this is going to the right 4 units. Log base 2x minus 4. Now, the difference between here are the parentheses. The 4 is in the log on this one. It's outside the log on that one. So we want to, this is an up and down motion. So this is negative, so it's going to go down. So this will be down 4 units. So the parentheses matter big. It's tucked inside the log or not. Here I'm making x negative. I'm changing the input to be negative. This is changing the output to be negative. This is changing the input to be negative. So this is a reflection of x going from positive to negative. So it's reflected over the y-axis. Okay, that concludes video 4. I'll see you guys in the next video.